Most of the world can't be represented by digital numbers. You might have a temperature sensor, you might have a pressure sensor or a strain sensor that gives you a signal that looks like this. It's continuous in time and amplitude. It's an analog signal. Your microcontroller is used to computing with numbers that are digital. Microcontrollers can often have peripherals to help you translate between the two worlds. To go from this direction, you would use something like an analog to digital converter, an ADC, or A/D is often used, analog to digital. To go in the other direction, I might use something called a DAC, a digital to analog converter, or a D to A. So we already talked about the analog write functionality, so the Arduino approximates a DAC, or a digital to analog converter, using pulse width modulation. But now we'll talk a little bit about the analog to digital conversion that's offered by the microcontroller on the Arduino. So much like I was able to provide approximate analog outputs using the analog write command, I also have an analog read command, a read function, that takes a pin as an input and provides an integer output. Right? And what you'll see if you look at your Arduino closely, you have these pins on this side that all have the prefix A. And those are going to be my analog to digital converter pins, or my analog input pins. If I want to do any analog read on some sensor data, these are the pins I'm going to use. Right? The return values I get from analog read are going to be dependent on the analog to digital converter that's on my microcontroller. And so if I look at the data sheet, the Arduino Uno has a 328. If I look at the data sheet, I can actually find in here that I have an 8-channel 10-bit analog to digital converter in the DIP package, which is actually what I have. Same thing, I just have a 6-channel ADC. So I have 0, 1, 2, 3, 4, 5. Those are my 6 channels. Right? And a 10-bit number, remember, 2 to the 10 is going to give me return values between 0 and 1023. And this is a little different than the analog write command, which only took an 8-bit number between 0 to 255. So when I'm reading an analog signal, I'll be getting a return value of 0 to 1023. I'm going to set this up using a very simple circuit with a potentiometer. A potentiometer is just a variable resistor. So the nominal resistance of this might be something like a kiloohm or 10 kiloohms. But a potentiometer has a third terminal, and we often refer to that as the wiper. And so the wiper can effectively move between these terminals. So between these outer terminals, my resistance is always going to measure my nominal resistance, let's say 10 kiloohms. If I move the wiper all the way close to one end, I'll effectively read 0 resistance between these two things, or maybe a very small resistance if I can only get close to the end. If I move the wiper all the way to the other end of my resistor, I'm effectively measuring the entire resistance between this terminal and my wiper terminal. And obviously I can measure resistance anywhere in between as well, so I can think of this as a voltage divider of sorts. So I can set up my potentiometer something like this voltage divider, where I have one resistance here, I have another resistance here, and those resistances are going to depend on the current position of the wiper. As I'm turning that potentiometer, I'll change that wiper position. Right? And so these could vary between R1 plus R2 are always going to equal the nominal resistance of the potentiometer, say 10 kiloohms, but they can vary between, R1 could vary between 0 and that 10 kiloohms. And so a very common configuration is to set one side of the potentiometer to 5 volts, the other side to ground, and then my wiper I can send to one of those analog input pins, let's say A3 for example. And so now I can do an analog read on A3 and actually get some sense as to what the current position of that knob on my potentiometer is. So that's exactly what I've set up on my Arduino here. So I have my potentiometer, I have one side of that connected to 5 volts, I have the other side of that connected to ground, and then I have my wiper terminal, which is typically the middle terminal, connected up to one of my analog input pins. And then for grins here, what I'm going to do is use that knob position to adjust the brightness using an analog write command of this LED. So I have this LED through a current limiting resistor hooked up to one of my PWM pins. And so as I change that knob, the position of that knob, I can adjust the brightness of my LED. So I turn it back all the way the other way, and the LED turns off. So let's see how I did that. This is a very simple code here. I specify my pins as output and input. So an analog input is always going to have to be set up as an input pin here. And I then in my loop function, I am reading in value from that potentiometer pin. And then I write to my LED pin that potentiometer value divided by 4. And I do that because remember my potentiometer, my analog read, my ADC is giving me a 10-bit value. Between 0 and 1023, I can use an 8-bit value for my analog write command. So if I want it to have maximum brightness at the maximum potentiometer wiper position, I need to divide that by 4. And then I'm also going to print the current value of the potentiometer onto the serial port so that you can see that in operation. So if I look at my serial port right now and I turn this potentiometer, you can see those values slowly increasing. So they've made it all the way up to 1023. I can go to somewhere about halfway, around 512 or so as well. So I can play around with that potentiometer. Obviously I can use a lot of different sensors instead of just a potentiometer to actually read values in on that analog, using that analog read function in the ADC on my Arduino.